Alright, we're back. We're trying to solve exponential functions. I told you guys in Math 1, you don't have to solve every type of exponential function. I told you in math, many things have inverses. The inverse to addition, subtraction, vice versa. Inverse to multiplication, division, vice versa. So when you solve these equations, you have to use the inverse operation. Squaring and square rooting. Cubing and cube rooting if you want to go that route. Exponential functions also have an inverse, something that undoes it. Those are called logarithms. And I'm definitely not doing logarithms here. Okay, it's kind of annoying. I'm not a big fan. You guys don't learn it until Math 2 or Math 3. Maybe Math 3, I have no idea, actually. But regardless, we're not doing it here. So I promise you that these functions, or these equations, can be solved without logarithms. So let's take a look. The first example, we have 2 raised to the x plus 1 power equals 2 raised to the 4x minus 3 power. You can pause the video now and think about how we can do this, or you can just keep following along. If I have 2 cubed equals 2 raised to the x, and I want to figure out what x is, I mean, 2 cubed is 8. 2 raised to some power has to be 8. The powers have to be the same. There is no way to get 8 any other way here. 2 cubed has to equal 2 cubed. So when you have common bases, when you have the same base, the powers have to be equal. So for example here, 2 is my base, raised to the x plus 1 power. 2 is my base, raised to the 4x minus 3 power. That means x plus 1 has to be equal to 4x minus 3. That is the only way you can have common bases equaling each other with the same exponent. The exponents have to be the same. Don't even worry about the bases anymore. We don't care. We do care that they're common. We don't care once we start solving them. So now we just have a regular multi-step equation. Subtract x on both sides. I get 1 equals 3x minus 3. Add 3, add 3. I get 4 equals 3x. That means x equals 4/3. Boom, done. That's it. It's easy. Once you understand that if the bases are the same, that means the exponents have to be the same. Again, 2 cubed has to equal 2 cubed. 2 cubed can't equal 2 to the 5th power. That's going to be 8 equaling 32, which doesn't make sense. Again, the exponents have to be the same. So if you don't understand what I'm saying, if you can't follow along, just know the exponents have to be the same, along with the bases, obviously. Next one. 3 to the 3x minus 2 power equals 27 raised to the second, or raised to the 2x power. Mr. Z, clearly the bases aren't the same. That's 3, that's 27. You're right. You're right. They aren't the same. What do we do now? You can pause the video. You can think about, alright, 3 and 27. What is the connection between 3 and 27? So you can try to figure this out yourself, or you can follow along. If I'm looking at this, 27, I need these bases to be the same. How can I make 27 the same base as 3? How can... Oh! 27 is just 3 cubed. We can rewrite bases using exponents. Now, when you have this is where the exponent laws come into play. 3 to the 3x minus 2 power has to be, well, this is power to a power, guys. Power to a power means we multiply the exponents. That's 6x. We have like bases. Boom, done. 3x minus 2 equals 6x. Again, once you have common bases, all you need is to set the exponents equal. Get a common base, set the exponents equal, and you're done. Besides, you have to solve it. Subtract 3x. Negative 2 equals 3x. Divide by 3. x equals negative 2/3. I'll box this one too because cool kids box answers. Again, that's it, guys. That's basically the process. Get a common base. Once you have a common base, set the exponents equal, and you're done. Easy. Easy as 1, 2, 3. Do, re, mi. A, B, C. Yeah, I know. I'm lame. Next one, 49 to the x equals 7 to the 2/3 power. If you guys want to pause the video now, you can start solving the rest of these because they all follow the same suit, maybe except this last one, which you kind of have to do something with first. But follow along. We know 49, 7. These aren't the same bases. If only I can make 49 the same base as 7. Oh, 49 is just 7 squared. Oh, 7, again, exponent laws. Power to a power means I multiply 7 to the 2x equals 7 to the 2/3. That means 2x equals 2/3 because, again, if our bases are the same, then my exponents have to be the same. Divide by 2. If I do 2/3 divided by 2, which also means 2/3 times 1/2, because we know that when you when you divide with fractions, you multiply by the reciprocal. That just gives you 1/3. Easy. Nothing to it. Boom. Drop the mic. Okay, I'm done. Last one. These bases aren't the same. I can't make 8 a base of 4. 4 squared is not 8. 4 squared is 16. Okay? So there is no way to make this 8 a base of 4. But when you have bases like this, try to think of a base they have in common. 4 and 8. Well, I know 4 is just 2 squared. And I know 8 is just 2 cubed. So in this essence, neither were the base we were looking for, but we can understand how to get to that base. So when you have problems like this, guys, make sure you always find the correct base. 4 is just 2 squared. 8 is just 2 cubed. Using laws of exponents, I have to multiply, so this is going to be 2 to the 10x power. When you multiply this, make sure you distribute. It's going to be 2 to the 6x plus 15. We now have common bases. Once you have common bases, make sure the exponents are the same. 6x plus 15 equals 10x. I'm going to subtract 6x on both sides. I'm going to have 15 equals 4x. Divide by 4. And x equals 15/4. I get the lines aren't connecting, but whatever. So, again, guys, that's how you solve certain types of exponential functions. Again, these are the basic ones that we're going to solve in Math 1. We aren't going to go into logarithms because it's not needed. So again, your main goal, find common bases. I can't write on this paper. And then set exponents equal. 2 steps. Find common bases, set exponents equal. And that's why it's important to never forget the exponent laws, guys, because again, you have to use power to a power here when you have an exponent raised to a power. So, there are 4 questions below for you guys to practice on. You can hit the pause button, try them yourself, which I advise to do, and then you can hit play, figure out the answers, follow along just to check them. I'm going to fly through these 4 very quickly because once you can do one, guys, you can do them all. It's just repetitive, practicing it, getting the procedure down over and over and over again. So, hit the pause button, try them yourself. I'm going to keep moving on. We're going to see what happens. Number 1, both bases are the same. So, once both bases are the same, I'm going to set the exponents equal. So, the exponents are going to be 3x minus 1 equals negative 4x plus 5. Multi-step equation, I'm going to add 4x to both sides. I get 7x minus 1 equals 5. add 1, add 1. I get 7x equals 6. Divide by 7, x equals 6/7. Told you. Easy. Once you get the hang of it, boom, 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 we're done. Okay? Moving on. Second one, 5, 125. Again, my first step is always find out if the bases are the same. 5 and 125 are not the same base. I promise you, though, if they're not the same base, there is a base they have in common. 5 is already in the lowest base it can be. 125 is not. If you guys don't know what 125 is and you can't guess, I mean, you can use your intuition and kind of be like, oh, wait, it's not squared. Maybe it's cubed. Let's check it out. Yeah, 125 is 5 cubed. So 5 raised to the 5x minus 9 power equals 5 cubed, which is 125 raised to the 4x plus 7 power. Remember your power to a power rule. 5x minus 9 has to be power to a power, means you multiply. Make sure you distribute these numbers through. 12x plus 21. So, once you have it here, it's just solving a multi-step equation. Subtract 5x on both sides. You have negative 9 equals 7, not 17, 7x plus 21. I'm going to subtract 21. 7x equals negative 30. If I subtract 21, negative 9 minus 21 is negative 30. Divide by 7. X equals negative 30 over 7. Sorry I'm not showing all my work, guys. I'm running out of space because I also can't write tiny with these markers because these markers are not that fine-pointed. Questions? I can't answer them anyways because I'm not there. Next one. 9 raised to the 2x, 27 raised to the 4x minus 2. Again, if I try to break down 27, it's not 9 squared, it's not 9 cubed. 9's also not in the lowest base. 9 and 27 do have a common base though, because 9 is just 3 squared, and 27 is just 3 cubed. Power to a power means I have 4x equals, well, that's going to be 12x because I multiply, minus 6. Multi-step equations. I am not subtracting 4x. I'm going to subtract 12x because if I subtract 4x, I have nothing left on this side. It's going to involve another step. So instead, I'm going to bring the x over, isolate the variable already. That's going to be negative 8x equals negative 6, divide by negative 8, divide by negative 8. X equals 6/8, or otherwise known as positive 3/4. Last one, guys, 36 and 6. 36 and 6 are already not common bases, but you can know what 36 is. 36 is just 6 squared. Raised to the 2x power, and 6 is already in its lowest base. So again, once you have the same base, power to a power rule right here. 2 times 2x is 4x. Multiply the exponents equals 4/3. If I'm going to divide by 4, that's the same as multiplying by 1/4. Because again, when we divide by a number, you can also multiply by the reciprocal. That's just common knowledge. So if I do 4/3 multiplied by the reciprocal, I'm going to get 1/3. Again, guys, that's just fraction work, okay? So that is solving the exponential functions that we have to solve in Math 1. There's nothing else to it. Hopefully you guys understood the process. Hopefully after these 8 problems that you guys had the procedure down pretty well. That's basically almost everything we have to do with exponential functions besides creating exponential functions in terms of geometric sequences. So you guys have already created exponential functions with growth and decay rates. We're going to kind of take that, but instead look at charts and create functions based off of charts, not just word problems. But that's later to come. Not this week, probably next. So guys, hopefully you got this. If you didn't, rewatch the videos. Ask me for help if you need to. Otherwise, hope you understood everything. I'll see you guys later.